Alright, I need to tell you about someone who was right about something for 2,000 years before anyone could prove it. 2,000 years. Imagine that. Imagine seeing something so clearly, understanding something so profoundly, that you're correct about a fundamental truth of the universe, and then humanity takes 20 centuries to catch up with you. That's not just being ahead of your time, that's being ahead of your entire civilization's ability to verify what you're saying. Here's what I want you to picture. It's a clear night in the 4th century BCE. You're standing on the coast of Asia Minor, what we now call Turkey, and you look up at the sky. And there it is. A comet. This blazing streak of light with a tail, moving across the heavens in ways that nothing else does. Everyone around you is terrified. They're whispering about what disaster this foretells. War? Plague? The death of a king? The gods are sending a message, and it's not good. But there's this one guy, this philosopher named Appollonius, and he's calm. He's observing. He's taking notes. And he's thinking something that would get him laughed out of every philosophical school in Greece. He's thinking, that's not an omen. That's not a message from the gods. That's not even an atmospheric phenomenon like everyone says. That's a celestial body. That's a real, permanent object out there in space, following its own path through the cosmos. Now, why should you care about some obscure ancient philosopher you've never heard of? Because Appollonius of Myndus represents something we desperately need to understand. Intellectual courage looks like standing alone when everyone else is wrong. And I mean everyone. The greatest minds of his age, Aristotle himself, believed comets were atmospheric phenomena, temporary vapors catching fire in the upper air. The religious authorities said they were divine omens. The conventional wisdom was unanimous. And Appollonius said, no, you're all wrong. This isn't just a story about astronomy. This isn't just ancient history trivia. This is about what happens when someone has the courage to trust observation over authority, to propose natural explanations when supernatural ones dominate, to synthesize knowledge from different cultures when everyone else is being intellectually tribal. This is about a forgotten pioneer who bridged ancient Mesopotamian wisdom and Greek rational inquiry, who challenged myths with observation and logic, who saw the cosmos differently than anyone else in his time. And here's the kicker. Here's what makes this story matter right now, today, for you. He was almost completely forgotten. His works didn't survive. His name got overshadowed by other, more famous philosophers. He exists now only in a handful of citations, fragments, scattered references. But his idea survived. His approach survived, his example survived. And that tells us something profound about what really matters in intellectual life, about what it means to contribute to human understanding, about the difference between fame and significance. So here's what we're going to do today. We're going to resurrect Appollonius of Myndus from the dustbin of history. We're going to understand who he was, what he claimed, why it was revolutionary, and why it matters not just for the history of astronomy, but for how we think, how we question, how we live philosophically. We're going to see how one person's intellectual courage, working at the crossroads of cultures, synthesizing different traditions, asking better questions, how that can point toward truth, even when the tools to prove it won't exist for 2 millennia. And we're going to ask ourselves, what would it mean to have that kind of courage? To care more about truth than recognition? To be willing to stand alone when the evidence demands it? Because that's what philosophy is really about. Not memorizing dead people's opinions, but learning to think courageously and well, learning to question, learning to observe, learning to seek truth wherever it leads, even if you're forgotten, even if no one remembers your name, even if it takes 2,000 years for humanity to prove you right. Who was Appollonius of Myndus? All right, let's talk about someone you've probably never heard of, and that's exactly the problem. Picture this. It's the 4th century BCE. Greek philosophy is exploding with ideas. Plato's academy is in full swing. Aristotle is cataloging everything in the known universe. And in a small city called Myndus, tucked away in what we now call Turkey, there's this guy Appollonius who's about to say something so radical, so far ahead of his time, that it won't be proven correct for nearly 2,000 years. But here's the thing, we almost lost him to history. Not because his ideas weren't brilliant, not because he wasn't influential, but because he had the misfortune of sharing a name with other, more famous philosophers. It's like being named John Smith. in a world that only remembers the famous John Smiths. So why are we talking about him today? Because Apollonius of Myndus represents something crucial about how philosophy actually works. It's not just the famous names, the Platos and Aristotles. It's also these bridge figures, these intellectual smugglers who carried ideas across cultures and challenged the conventional wisdom of their age. Now let's establish where and when we are, because context matters profoundly here. The 4th century BCE was one of the most intellectually fertile periods in human history. This is the century of Alexander the Great, whose conquests would soon spread Greek culture across 3 continents. But more importantly for our purposes, this is a moment when Greek philosophy is really encountering for the first time the ancient wisdom traditions of the Near East. Apollonius lived in Myndus, an ancient city in Asia Minor. This geographical detail is not trivial. Asia Minor was a crossroads literally and intellectually. It's where Greek rationalism met Mesopotamian mysticism, where Hellenic philosophy encountered Chaldean astronomy, where the new met the ancient. And this is crucial. Apollonius wasn't just geographically positioned at this crossroads. He intellectually inhabited it. He was bilingual, not just in language, but in thought systems. He could speak the language of Greek philosophical inquiry and the language of Chaldean astronomical wisdom. Here's where it gets interesting. Most Greek philosophers of this period were, let's be honest, a bit snobbish about barbarian knowledge. Sure, they'd acknowledge that the Egyptians and Babylonians had been observing the stars for millennia, but they saw themselves as the ones who would finally make sense of it all through pure reason. Not Apollonius. He claimed direct lineage to Chaldean astronomical wisdom. Not metaphorical lineage, he studied their methods, their observations, their accumulated knowledge from centuries of priestly skywatching in Mesopotamia. Think about what this means. The Chaldeans had been systematically observing celestial patterns since before the Greeks even had a written language. They had records, predictions, mathematical models. And Apollonius said, I'm going to take this seriously, I'm going to learn from it, and I'm going to integrate it with Greek philosophical methods. This made him unique. He was a master of horoscopes, which sounds mystical to our modern ears, but remember, astrology and astronomy weren't separated yet. He was doing what we'd now call observational astronomy, but within a framework that still included astrological interpretation. And this is what makes him so fascinating. He's standing right at that moment in history when observation is starting to challenge superstition, when careful record-keeping is beginning to reveal patterns that can't be explained by mythology alone. But to really understand Apollonius, we need to understand where he got his knowledge. We need to talk about the Chaldeans. The Chaldean connection, let's go back. Way back. To ancient Mesopotamia, the land between the Tigris and Euphrates rivers, what we now call Iraq. For over 2,000 years before Apollonius was even born, the Chaldeans served as priest astronomers. These weren't just religious figures performing rituals. They were systematic observers of the heavens, meticulously recording celestial events night after night, generation after generation. Why? Because in Mesopotamian culture, the heavens and human affairs were intimately connected. Kings needed to know what the stars foretold. Agricultural cycles depended on celestial timing. The entire social order was, in some sense, written in the sky. So these priest astronomers developed something remarkable. A tradition of careful, systematic observation that spanned centuries. They recorded eclipses, planetary movements, the appearance of comets. They developed mathematical models to predict celestial events. They created what we might call the first astronomical databases. This wasn't mysticism for mysticism's sake. This was practical knowledge, hard-won through generations of patient observation. Now here's what's extraordinary about Apollonius. He claimed to have inherited this knowledge. Think about what that means. Somehow, across cultural boundaries, across language barriers, across the divide between Greek and barbarian, this astronomical wisdom made its way to him. He studied it. He absorbed it. He made it his own. This is intellectual courage, people. In a Greek world that often dismissed non-Greek knowledge as inferior, Apollonius said, no. These Chaldeans have been watching the sky for 2 millennia. They know things we don't. I'm going to learn from them. And he didn't just learn their observations, he learned their methods, the careful attention to detail, the long-term thinking, the willingness to record everything, even events you don't yet understand. He blended this with Greek philosophical inquiry, the asking of why, questions, the demand for rational explanations, the systematic pursuit of understanding. This positioning made Apollonius something rare and precious, a cultural bridge. He was transmitting esoteric mystical knowledge into the Greek world, yes, but he was also doing something more subtle and more important. He was showing Greek thinkers that there were other ways of knowing, other intellectual traditions worth engaging with seriously. The Greek philosophical tradition tends to get all the credit in Western intellectual history, and don't get me wrong, it deserves enormous credit. But it didn't emerge in a vacuum. It was enriched, challenged, and expanded by encounters with other traditions. Apollonius embodied that encounter. He helped transform how Hellenic thinkers approached the cosmos. He brought Mesopotamian patience and observational rigor into conversation with Greek rationalism and systematic inquiry. And this matters because here's the thing, philosophy at its best has always been a conversation across cultures, across traditions, across ways of seeing the world. When we forget that, when we treat philosophy as the exclusive property of one tradition, we impoverish ourselves. But Apollonius didn't just transmit ancient wisdom. He challenged it. He questioned it. And he came up with an idea about comets that was so radical, so contrary to everything people believed, that we need to talk about it next. Okay, now we get to the moment that makes Apollonius absolutely fascinating. Imagine you're living in the ancient world. You look up at the night sky, and suddenly there it is. A comet. This blazing streak of light with a tail, appearing out of nowhere, moving across the heavens in ways that planets don't, that stars don't. It's terrifying. It's beautiful. It's utterly inexplicable. What do you think it is? Throughout the ancient world, Greek, Roman, Chinese, you name it, comets were seen as omens, and not good omens. These were portents of disaster, divine warnings, atmospheric disturbances that signaled war, plague, the death of kings. Aristotle himself, arguably the greatest scientific mind of the ancient world, believed comets were atmospheric phenomena. He thought they were vapors in the upper air that caught fire, temporary, terrestrial, essentially weather events that happened to look dramatic. This wasn't unreasonable, by the way. Comets do appear suddenly and unpredictably. They don't follow the regular patterns of planets. They seem to come from nowhere and disappear back into nothing. If you're trying to make sense of the cosmos with the tools available in the 4th century BCE, atmospheric phenomenon is actually a pretty logical conclusion. And the omen interpretation? That made sense too. These things appeared before major historical events, or at least people remembered them that way. Confirmation bias is as old as humanity. A comet appears, and 6 months later a king dies, and everyone says, "See, the heavens warned us." This was the prevailing wisdom. This is what educated people believed. This is what the greatest minds of the age taught. And then there's Appollonius of Myndus, standing in his observatory in Asia Minor, and he says something absolutely extraordinary. No, you're all wrong. Comets aren't atmospheric phenomena. They're not omens. They're not temporary vapors catching fire in the upper air. They're celestial bodies. They're as real and permanent as the sun and the moon. They're out there in the heavens, following their own paths. Let me be clear about how radical this was. This wasn't a minor disagreement about details. This was a complete reconceptualization of what comets are. He's saying, when a comet appears, it's not appearing. It's not being created in that moment. It's been there all along, following its own orbit through space, and we're only seeing it when it comes close enough to Earth or when conditions make it visible. This is extraordinary. This is astronomical thinking that wouldn't be proven correct until, and I want you to really hear this, until nearly 2,000 years later. Now, how do we know Apollonius said this? Because we have his words preserved by Seneca the Younger, the Roman Stoic philosopher, writing in the 1st century CE. Seneca was writing his Natural Questions, and when he got to the section on comets, he cited Apollonius. Think about that chain of transmission. Apollonius in the 4th century BCE makes this claim. It gets recorded, passed down, and 400 years later, Seneca thinks it's important enough to preserve in his own work. Seneca himself was skeptical of the prevailing view that comets were omens or atmospheric phenomena. He was looking for natural explanations. And when he found Apollonius's theory, he recognized something valuable, an ancient voice arguing for what we'd now call a scientific approach to celestial phenomena. Here's what blows my mind about this. Apollonius wouldn't be proven right until the work of Tycho Brahe in the 16th century, who demonstrated that comets were beyond the moon's orbit, that they were celestial, not atmospheric. And we wouldn't fully understand comet orbits until Edmund Halley in the 18th century predicted the return of the comet that now bears his name. That's 2,000 years. 2 millennia between Apollonius saying comets are celestial bodies and humanity actually proving it. How did he know? Or rather, because he couldn't have known in the way we know, how did he have the intellectual courage to propose something so contrary to the prevailing wisdom? This is where that Chaldean connection becomes crucial. The Chaldeans had been recording comet appearances for centuries. They had data, lots of data. And maybe Apollonius looked at that data and saw patterns that suggested these weren't random atmospheric events, but recurring celestial phenomena. Or maybe it was pure philosophical reasoning. Maybe he thought, if the cosmos is ordered, if the heavens follow rational principles, then these dramatic appearances must have natural explanations. They must be part of the celestial order, not disruptions of it. Whatever his reasoning, he was right. Spectacularly, remarkably, 2,000 years ahead of his time right. But what did this actually look like? How did Apollonius envision the cosmos? Let's visualize his revolutionary perspective. Okay, I want you to do something with me. Close your eyes for a moment, keep them open enough to listen, but imagine this with me. You're standing with Apollonius on a clear night in Myndus. The Mediterranean stretches out to the west. Above you, the sky is absolutely brilliant with stars, no light pollution, remember? Just the pure darkness of the ancient world making every star visible. And there, moving slowly across the heavens, is a comet. Most people around you are frightened. They're whispering about what disaster it foretells. They're making offerings to the gods, trying to appease whatever divine anger this represents, but Apollonius is calm, he's observing, he's taking notes. And he's thinking something completely different. What Apollonius saw, or rather, what he conceptualized, was a fundamental reimagining of cosmic order. The prevailing view divided the universe into 2 realms, the terrestrial and the celestial. Earth was the realm of change, corruption, imperfection. The heavens were eternal, perfect, unchanging. The planets and stars moved in perfect circles because circles were perfect. Everything had its place in a cosmic hierarchy. Comets didn't fit this scheme. They appeared and disappeared. They moved irregularly. They had those strange tails. So the easiest explanation was, they're not really celestial. They're atmospheric. They belong to our realm of change and imperfection, not to the perfect heavens. Apollonius rejected this entire framework. He said, no, the heavens can include irregular movements. Celestial bodies can appear and disappear from our view. The cosmos is more complex, more dynamic than this rigid 2-realm model suggests. This is philosophical courage. This is someone willing to complicate the picture, to embrace mystery and complexity, rather than forcing observations to fit a neat theoretical framework. Here's what Apollonius was really doing and why it matters so profoundly. He was replacing supernatural explanation with natural explanation. He was replacing fear with curiosity. He was replacing omen reading with observation. This is the move. The fundamental move that makes science possible. It's the shift from asking, what do the gods mean by this? To asking, what is this actually doing? What patterns can we observe? What natural explanations might account for what we're seeing? And notice this doesn't require modern instruments. This doesn't require telescopes or spectroscopy or mathematical physics. This requires a change in thinking, a change in how you approach unexplained phenomena. Most people saw a comet and thought, omen, warning, fear. Apollonius saw a comet and thought, data point, celestial body. Let's observe and understand. That's revolutionary. That's the birth of scientific astronomy, right there, in one person's willingness to think differently. So what was Apollonius' cosmos like? Imagine a universe where celestial bodies, sun, moon, planets, stars, and comets all share the same space, the same realm. They're all out there in the heavens. They all follow natural principles, even if we don't yet understand all those principles. Some of these bodies we see all the time, the sun, the moon, the visible planets. Some we see regularly in predictable patterns, the stars, the known planets in their orbits. And some, the comets, we see only occasionally, when their paths bring them close enough to Earth or when they become bright enough to observe. But they're all real. They're all permanent. They're all part of the natural order. This is a cosmos of permanence and pattern, but also of mystery and discovery. It's a cosmos that invites observation rather than fear. It's a cosmos that can be studied, understood, mapped. It's a cosmos, in other words, that looks remarkably like the one we actually inhabit. And here's what gets me every single time I think about this. Apollonius was wrong about a lot of things. He was working within an astrological framework we'd now reject. He didn't have the mathematical tools to describe orbital mechanics. He couldn't have understood what comets actually are, icy bodies from the outer solar system, sublimating as they approach the sun. But he was right about the thing that mattered most. Comets are celestial bodies. They're permanent features of the cosmos. They follow natural laws. That insight, that single revolutionary insight, anticipated 2 millennia of astronomical discovery. And it came not from better instruments or more data, but from better thinking. From the courage to question received wisdom. From the willingness to propose natural explanations for mysterious phenomena. From the intellectual honesty to say, our current theories don't adequately explain what we observe, so we need better theories. This is philosophy at its best. This is what philosophy can do. It can change how we see the world. It can challenge us to think beyond the comfortable explanations. It can point us toward truth, even when we don't yet have all the tools to fully grasp that truth. But Apollonius didn't work in isolation. His ideas emerged from a specific intellectual context where philosophy and astronomy were beginning their long, complicated dance. Let's look at that broader picture. So we've established that Apollonius made this extraordinary claim about comets. But here's the question we need to ask. Why? What was happening in the intellectual world of the 4th century BCE that made this kind of thinking possible? Because ideas don't emerge in a vacuum. Revolutionary thoughts don't just pop into existence randomly. They emerge from contexts, from conversations, from tensions between different ways of seeing the world. And Apollonius was living right in the middle of one of the most productive intellectual tensions in human history. Let's talk about what was actually at stake here. For thousands of years, and I mean thousands, human beings explained natural phenomena through supernatural agency. Thunder? That's Zeus. Earthquakes? Poseidon's angry. Disease? Divine punishment. Comets? Messages from the gods. This isn't primitive thinking, by the way. This is sophisticated theological and cosmological reasoning. These explanations provided meaning, order, and moral framework for understanding a chaotic and often terrifying world. But starting in the 6th century BCE, something remarkable began happening in the Greek world. Thinkers started proposing natural explanations for natural phenomena. Thales said floods weren't divine punishment. They were natural events caused by physical processes. Anaximander proposed that lightning wasn't Zeus's thunderbolt, it was wind breaking out of clouds. Democritus suggested that everything was made of atoms moving in void, no divine intervention required. This was early natural philosophy, what we'd now call science. And it was deeply controversial. Because if you remove supernatural explanations, you're not just changing your physics, you're changing your entire worldview. You're challenging religious authority. You're questioning the moral order of the universe. So by Apollonius' time, the 4th century BCE, there's this massive intellectual battle happening. On one side, you have traditional religious and mythological explanations. The gods control the cosmos. Celestial events have meaning, they're messages, omens, warnings. The universe is fundamentally about divine will and human fate. On the other side, you have natural philosophers arguing for rational physical explanations. The cosmos operates according to natural laws. Celestial events can be understood through observation and reason. The universe is fundamentally about matter and motion and mathematical relationships. And here's what's crucial. Apollonius is working right at the intersection of these 2 worldviews. Remember, he's an astrologer. He believes in the connection between celestial events and human affairs. He's not a modern scientist rejecting all supernatural explanation, but he's also insisting on natural explanations for celestial phenomena themselves. He's saying, yes, the stars and planets may influence human life, that's his astrological framework, but they do so as real, physical, celestial bodies following natural principles, not as temporary atmospheric phenomena or arbitrary divine messages. This is the fascinating complexity of intellectual history. Progress doesn't happen in clean, linear steps. It happens through people who straddle multiple worldviews, who synthesize seemingly contradictory ideas, who advance understanding while still working within frameworks we'd now consider outdated. What Apollonius represents, and this is crucial for understanding the development of scientific thinking, is a methodical, rational approach to celestial phenomena, even while working within an astrological framework. Think about what this means practically. When Apollonius observes a comet, he's not just interpreting what it means for human affairs. He's asking, what is it? Where is it? How does it move? What are its physical properties? These are different questions. They require different methods, and they lead to different kinds of knowledge. The astrological question, what does this comet mean, leads to interpretation, to reading signs, to connecting celestial events with terrestrial outcomes. But the astronomical question, what is this comet, leads to observation, measurement, hypothesis, testing against future observations. Apollonius is doing both. And in doing both, he's helping to develop the observational and rational methods that will eventually separate astronomy from astrology, science from divination. He's not there yet. He can't be. The conceptual tools don't exist yet. But he's moving in that direction. He's showing that you can study the heavens systematically, rationally, empirically. Here's what I find so moving about this moment in history. Apollonius is living through an intellectual transition that will take centuries to complete. He's part of the long, messy, complicated process by which humanity moves from mythic to scientific understanding of the cosmos. And he's positioned uniquely, almost perfectly, to embody that transition. He's got one foot in ancient Mesopotamian mystical traditions, the Chaldean astronomical wisdom passed down through priestly lineages for millennia. He's got the other foot in Greek rational inquiry, the demand for logical explanations, the systematic pursuit of understanding through reason. And he's using both. He's not rejecting one for the other. He's synthesizing them. He's taking the observational rigor and long-term data collection of the Chaldeans and combining it with the philosophical questioning and rational analysis of the Greeks. This is how intellectual progress actually happens. Not through clean breaks with the past, but through creative synthesis. Not through rejecting everything that came before, but through transforming it, building on it, pushing it in new directions. But here's the problem with being a transitional figure, with being ahead of your time, with making revolutionary claims that won't be proven for 2,000 years. History might forget you, and that's exactly what almost happened to Apollonius. Now we need to confront something uncomfortable. We don't actually know very much about Appollonius of Myndus. And this isn't just an unfortunate gap in the historical record. This is a fundamental problem that affects how we understand the development of philosophical and scientific ideas. History tends to remember the famous, the influential. The people who founded schools, wrote numerous books, had famous students. History remembers Plato and Aristotle, Ptolemy and Euclid. But what about the people who had one brilliant insight? What about the thinkers who were influential in their own time, but whose works didn't survive? What about the intellectual bridge figures who transmitted ideas across cultures but didn't fit neatly into any single tradition? These people get lost, and Apollonius of Myndus almost got lost. Here's what makes this even more complicated. We're not even entirely sure which Apollonius we're talking about. There's a reference in Stephanus of Byzantium, a 6th century CE grammarian, to an Apollonius who was also a grammarian. Is that our Apollonius, the astronomer-philosopher from Myndus? Or is it a different Apollonius entirely? And this is the problem with ancient history. Names repeat, records are fragmentary. Different sources sometimes contradict each other. And when you're trying to reconstruct the life and work of someone who lived 2,400 years ago, you're working with pieces of a puzzle where most of the pieces are missing. Was Apollonius of Myndus also a grammarian? Did he write on language and literature as well as astronomy? Or are we conflating two different people who happen to share a common name? We don't know. And that uncertainty matters because it affects how we understand his intellectual range, his influences, his place in the broader cultural world of 4th century BCE Asia Minor. Let me be honest with you about what we actually have. We have Seneca's citation about comets. That's our primary source for Apollonius's astronomical views. We have a few other scattered references in later authors. We have the claim about his connection to Chaldean wisdom, and that's basically it. We don't have any complete works by Apollonius. We don't have detailed biographical information. We don't know who his teachers were, who his students were, what other ideas he developed, how his thinking evolved over his lifetime. This is fragmentary evidence. And from fragmentary evidence, we're trying to reconstruct not just a person, but an intellectual contribution that spans cultures and anticipates future scientific understanding by 2 millennia. This should make us humble. It should make us cautious about grand claims. But it should also make us appreciate what we do have, these preserved fragments that give us glimpses of a remarkable mind at work. But here's what's actually beautiful about this situation. Apollonius survives because other thinkers found his ideas valuable enough to preserve. Think about that chain of transmission. Apollonius makes his claim about comets in the 4th century BCE. Someone we don't know who records it, writes it down, preserves it. That text gets copied, passed along, studied. 400 years later, Seneca the Younger, writing in Rome, thinks this ancient Greek philosopher's idea is important enough to include in his Natural Questions. And then Seneca's work gets copied, preserved through the Middle Ages, transmitted to the Renaissance, printed, translated, studied. And here we are, 2,400 years later, talking about Apollonius's insight. This is how ideas survive. Not always through the original author's fame or influence, but through the recognition by later thinkers that something valuable was said, something worth preserving, something that speaks across centuries. Seneca didn't agree with everything Apollonius said, but he recognized the value of this alternative view, this challenge to conventional wisdom. He preserved it. And in preserving it, he gave Apollonius a kind of immortality. So what are we actually doing when we talk about Appollonius of Myndus? We're engaging in historical reconstruction. We're taking fragmentary evidence and trying to build a coherent picture. We're making informed guesses about context, influences, intellectual development, and we need to be honest about the limitations of this process. We can say with confidence, someone named Appollonius from Myndus claimed that comets were celestial bodies, not atmospheric phenomena. That claim was recorded and preserved by Seneca. That claim was remarkably prescient. We can say with reasonable confidence, this Apollonius claimed connection to Chaldean astronomical traditions. He was working in the 4th century BCE. He was positioned at a cultural crossroads between Greek and Near Eastern intellectual traditions. But beyond that, we're in the realm of informed speculation. We're connecting dots with dotted lines, not solid ones. We're building a picture that's plausible, that fits the evidence we have, but that remains necessarily incomplete. And you know what? The mystery itself is philosophically significant, because it reminds us that the history of ideas is not just the history of famous names and complete works. It's also the history of fragments, of lost voices, of ideas that survived by chance or by the recognition of later thinkers. How many other Apolloniuses are there? How many brilliant insights were made by people whose names we've lost, whose works didn't survive, who made crucial contributions to human understanding but left no trace in the historical record? This should make us humble about our narratives of intellectual progress. We tell the story of Western philosophy and science as a progression from the pre-Socratics through Plato and Aristotle, through Hellenistic philosophy, through medieval scholasticism, through the scientific revolution. But that's the story we can tell because those are the texts that survived. How many other stories are there? How many other voices? How many other insights that might have changed how we think if only they'd been preserved? Apollonius almost didn't make it. He survived by the thinnest of threads, a citation in Seneca, a few scattered references. But he did survive. And that survival gives us a glimpse of a richer, more complex intellectual world than our standard narratives usually acknowledge. But despite the gaps, despite the uncertainties, despite the fragmentary nature of what we know, Apollonius left a legacy. And that legacy tells us something profound about the nature of intellectual courage and the long arc of human understanding. Okay, so here's the paradox we need to wrestle with. Apollonius of Myndus was right about something that wouldn't be proven for 2,000 years. He made a claim so revolutionary, so ahead of its time, that it anticipated modern astronomy by millennia. And yet, most people have never heard of him. How does that happen? How does someone be spectacularly, remarkably correct about something fundamental and still get lost in the shuffle of history? And more importantly, does that mean his legacy doesn't matter? Or does it mean we need to think differently about what legacy actually means? Let's start with the uncomfortable truth. Apollonius of Myndus was overshadowed, and not just by Plato or Aristotle, the philosophical giants you'd expect to overshadow almost everyone. He was overshadowed by other people named Appollonius. There's Appollonius of Tyana, a 1st century CE philosopher and mystic who became legendary, almost Christ-like in later accounts. Miracle worker, sage, spiritual teacher. That Appollonius got famous. That Appollonius got biographies written about him. There's Appollonius of Perga, the great mathematician who wrote on conic sections, whose work influenced astronomy and mathematics for centuries. That Appollonius made it into the textbooks. And then there's our Appollonius. Appollonius of Myndus, the one who was right about comets, the one who bridged Chaldean and Greek traditions, the one who anticipated scientific astronomy. But he shared a common name. And in the ancient world, where texts were copied by hand, where libraries burned, where preservation was always precarious, sharing a name with more famous people was almost a death sentence for your historical survival. It's like being a brilliant musician named John Williams today. Good luck getting recognized when there's already a famous composer with that name. But here's what Appollonius actually accomplished and why it matters profoundly. He represents an early, courageous attempt to demystify celestial phenomena through reasoned philosophy rather than supernatural explanation. Let me unpack what that means. For most of human history, when something mysterious happened in the sky, a comet, an eclipse, a meteor shower, the default explanation was supernatural. The gods are angry. The heavens are sending a message. This is an omen of disaster. And these weren't just superstitions held by uneducated people. These were sophisticated theological and cosmological frameworks developed by the smartest people in their societies: priests, philosophers, court astronomers. Appollonius said, "No, we can explain this naturally. We can understand this through observation and reason. We don't need to invoke divine intervention or supernatural causation. This is the move. The fundamental intellectual move that makes science possible. It's not about having better instruments. The telescope wouldn't be invented for another 2,000 years. It's not about having better mathematics. The calculus needed to describe orbital mechanics wouldn't exist for millennia. It's about having the courage to say, natural phenomena have natural explanations. Our job is to observe carefully, reason clearly, and propose hypotheses that can be tested against future observations. That's what Appollonius did. And that's revolutionary. Now let's talk about something that often gets overlooked in histories of Western philosophy and science: the role of cultural bridge figures. We tend to tell the story of Western intellectual development as if it happened in isolation. The Greeks invented philosophy and science, the story goes. Then the Romans preserved it. Then medieval Europeans recovered it. Then the scientific revolution perfected it. But that's not how it actually happened. Greek philosophy and science were constantly in conversation with other intellectual traditions: Egyptian, Mesopotamian, Persian, Indian. And Appollonius was one of those bridge figures. He didn't just passively receive Chaldean astronomical wisdom, he actively engaged with it, synthesized it with Greek philosophical methods, and created something new. This is how intellectual progress actually works. Not through isolated genius, but through cultural exchange. Not through one tradition having all the answers, but through different traditions challenging and enriching each other. The Chaldeans had centuries of observational data and astronomical records. The Greeks had systematic philosophical methods and rational inquiry. Appollonius brought them together, and in doing so he enriched both traditions. He showed Greek philosophers that, barbarian, knowledge could be sophisticated and valuable. He showed that observational astronomy could be combined with philosophical reasoning. But here's what really matters about Apollonius's legacy. He inspired subsequent generations to question received wisdom about the cosmos and seek rational explanations. Think about Seneca, 400 years later, writing about comets. He's frustrated with the prevailing superstitions. He's looking for natural explanations. And he finds this ancient voice, Appollonius of Myndus, who had the courage to propose something different. Seneca doesn't just cite Appollonius as a curiosity. He uses Appollonius to make an argument. Look, even centuries ago, there were thinkers who recognized that comets might be celestial bodies. We should take this possibility seriously. We should observe more carefully. We should question our assumptions. This is legacy. Not fame, not having schools named after you, but having your ideas continue to challenge, provoke, inspire. And it continues beyond Seneca. Medieval Islamic astronomers working with ancient Greek and Chaldean texts continued to debate the nature of comets. Renaissance astronomers, rediscovering ancient sources, found these alternative views and used them to challenge Aristotelian orthodoxy. Tycho Brahe, in the 16th century, when he proved that comets were beyond the moon's orbit, was he aware of Apollonius? Probably not directly. But he was part of an intellectual tradition that Apollonius helped create. The tradition of questioning received wisdom, of trusting observation over authority, of seeking natural explanations for celestial phenomena. So Apollonius's influence was quiet. It was indirect. It worked through citations and references, through ideas that survived even when his name was forgotten. But it was real. It mattered. It contributed to the long, slow process by which humanity moved from supernatural to natural explanations of the cosmos. And maybe that's the most important kind of legacy. Not the loud, obvious influence of famous founders of schools, but the quiet, persistent influence of ideas that keep challenging people to think differently, to question assumptions, to seek truth beyond conventional wisdom. Which brings us to the question, why does any of this matter today? Why should we in the 21st century care about an obscure 4th century BCE philosopher who made one brilliant claim about comets? Let me tell you why this matters more than you might think. Alright, I want to bring this home. Because we're not just doing ancient history here. We're not just cataloging forgotten philosophers for the sake of completeness. Appollonius of Myndus has something to teach us right now, today, in our contemporary world. And it's not about comets. It's about how we think, how we challenge assumptions, how we relate to knowledge and authority, how we navigate between different ways of understanding the world. So let's talk about why this ancient philosopher matters in the 21st century. First, Apollonius is an early exemplar of challenging prevailing myths with careful observation and logical reasoning. Now, we don't live in a world where people think comets are omens anymore. We've got that one figured out. But we absolutely live in a world full of prevailing myths, widely believed claims that aren't supported by evidence, that persist because they're comfortable or convenient or profitable for someone. Think about it. How many things do we believe simply because everyone knows they're true? How many explanations do we accept because they're traditional or because authorities endorse them without actually examining the evidence? Apollonius shows us what intellectual courage looks like. It looks like someone standing up and saying, I know this is what everyone believes. I know this is what the authorities teach. I know this is the conventional wisdom. But I've looked at the evidence, and I think we're wrong. That's hard. It was hard in the 4th century BCE, and it's hard now. Because challenging prevailing myths means challenging power structures, social consensus, comfortable certainties. But it's necessary. It's how we make progress. It's how we move from error toward truth. And Apollonius demonstrates something crucial. You don't need perfect evidence to challenge bad explanations. You need careful observation, logical reasoning, and the courage to propose alternatives. He didn't have a telescope, he didn't have spectroscopy, he didn't have orbital mechanics, but he had observations that didn't fit the prevailing theory, and he had the intellectual honesty to say so. That's a model for how we should approach any claim, any received wisdom, any everyone knows assumption. Observe carefully, reason clearly, have the courage to question. Second, Apollonius' approach foreshadows the scientific revolution's methodology. And I want to be really clear about what I mean here. I'm not saying Apollonius was doing modern science. He wasn't. He was working within an astrological framework. He didn't have the mathematical tools or experimental methods that define modern science, but he was doing something that would become essential to science. He was proposing hypotheses based on observation, and those hypotheses were, in principle, testable against future observations. Think about the scientific method as we understand it today. Observe phenomena, identify patterns or anomalies, propose hypotheses to explain what you observe. Test those hypotheses against new observations. Revise your understanding based on the results. Apollonius was doing this. He observed comets. He recognized that the prevailing explanation atmospheric phenomena didn't adequately account for what was observed. He proposed an alternative celestial bodies. And that alternative could be tested. If comets are celestial bodies, they should behave in certain ways, appear in certain patterns. He didn't have the tools to complete that testing. But he set up the question in a way that made testing possible eventually when the tools became available. This is the intellectual foundation of science, not instruments, not mathematics, not laboratories, but this way of thinking, observation, hypothesis, testing, revision. And it can happen anywhere, anytime, with any level of technology as long as you have people willing to observe carefully and think clearly. Third, Apollonius reminds us of the rich, diverse, and often surprising roots of Western philosophical and scientific thought. We have this tendency, and I see it all the time in how philosophy and science are taught to create clean linear narratives. The Greeks invented rational thought, then the Romans preserved it. Then it was lost in the Dark Ages, then it was recovered in the Renaissance. Then the scientific revolution perfected it. But that's not history, that's mythology. It's a simplified story that erases complexity, diversity, cultural exchange, and the contributions of non-Western traditions. Apollonius disrupts that narrative. He's a Greek philosopher, yes, but one who's deeply engaged with Mesopotamian astronomical traditions. He's working at a cultural crossroads, synthesizing different ways of knowing. And this matters because our contemporary intellectual challenges require exactly this kind of cross-cultural synthesis. We need to draw on multiple traditions, multiple ways of knowing, multiple perspectives. Climate science needs to integrate indigenous ecological knowledge with modern atmospheric physics. Medicine needs to learn from traditional healing practices while maintaining scientific rigor. Philosophy needs to engage seriously with non-Western philosophical traditions, not just as exotic curiosities but as genuine sources of insight. Apollonius models this. He didn't say Greek philosophy is superior, so I'll ignore Chaldean astronomy. He didn't say Chaldean astronomy is ancient wisdom, so I'll reject Greek rational methods. He synthesized them. He used both. That's what we need to do. And Apollonius, 2,400 years ago, shows us it's possible. But here's the deepest lesson, the one that really matters. Apollonius inspires us to question established beliefs, observe carefully, and seek truth beyond superstition and conventional wisdom. This isn't just about science. This isn't just about astronomy or philosophy. This is about how we live our lives. Every day, we're confronted with claims, with conventional wisdom, with everyone knows statements. About politics, about health, about relationships, about what makes a good life, about what's possible and what's not. And every day we have a choice. We can accept those claims uncritically. We can go along with conventional wisdom because it's easier, because it's what everyone else believes, because challenging it might be uncomfortable or unpopular. Or we can be like Apollonius. We can observe carefully. We can think clearly. We can have the courage to say, I'm not sure that's right. Let me look at the evidence. Let me reason through this. Let me propose an alternative. That's intellectual courage, that's philosophical practice, that's what it means to take thinking seriously. And sometimes, not always, but sometimes you'll be right. You'll see something others missed. You'll understand something others haven't grasped yet. You'll be 2,000 years ahead of your time. But even when you're wrong, even when your alternative hypothesis doesn't pan out, you've done something valuable. You've questioned, you've thought. You've refused to accept claims on authority alone. That's what Apollonius teaches us. Not the specific claim about comets we've got that figured out now, but the stance, the approach, the intellectual courage to challenge prevailing wisdom when the evidence suggests we should. So yes, Apollonius of Myndus is an obscure ancient philosopher. Yes, most of his work is lost. Yes, he was overshadowed by more famous thinkers, but he was right about something important when everyone else was wrong. He had the courage to propose a natural explanation when supernatural explanations were dominant. He synthesized different intellectual traditions to create new understanding. And 2,400 years later, we're still learning from him, not just about comets, but about how to think, how to question, how to seek truth. That's legacy. That's what matters. That's why we study philosophy not to memorize names and dates, but to learn from people who thought courageously and well, who challenged their age's assumptions, who pointed toward truth even when they couldn't fully grasp it. Apollonius of Myndus did that, and we would do well to follow his example, so we've seen who Apollonius was, what he claimed, why it mattered, and why it still matters today. But let me leave you with one final thought about what it means to be a forgotten pioneer. We've covered a lot of ground here, from ancient Myndus to Chaldean astronomy, from revolutionary claims about comets to the nature of intellectual courage. from historical fragments to contemporary relevance. But let me bring this all together with what I think is the central lesson of Appollonius of Myndus. Intellectual progress is not a straight line from ignorance to knowledge. It's not a simple story of great men having brilliant insights that immediately transform understanding. It's messy. It's complicated. It involves forgotten pioneers and lost ideas. It involves people who were right but couldn't prove it. It involves insights that had to wait centuries for the tools to verify them. It involves cultural exchange and synthesis that gets erased from our simplified narratives. Apollonius shows us this complexity. He was right about comets being celestial bodies, but he was working within an astrological framework we'd now reject. He synthesized Chaldean and Greek traditions, but we barely remember his name. He anticipated modern astronomy by 2 millennia, but he couldn't prove his claim with the tools available to him. This is what real intellectual history looks like, not clean, not simple. Not a triumphant march from darkness to light, but still, and this is crucial, still progress, still movement toward truth, still the accumulation of understanding across generations. And here's what I think we owe to the forgotten pioneers. We owe them remembrance. Yes. That's why we're here, talking about Appollonius of Myndus when most philosophy courses would skip right over him. But we owe them more than that. We owe them the continuation of their work. Appollonius had the courage to challenge prevailing wisdom about comets. We should have the courage to challenge prevailing wisdom in our own fields, our own thinking, our own lives. Appollonius synthesized different intellectual traditions to create new understanding. We should be willing to learn from diverse sources, to integrate different ways of knowing, to resist intellectual tribalism. Appollonius proposed hypotheses he couldn't yet prove, trusting that future observations would vindicate or refute his claims. We should be willing to think beyond what we can immediately verify, to propose bold ideas, to point toward truths we can glimpse but not yet fully grasp. That's how we honor forgotten pioneers. Not just by remembering their names, but by continuing their approach, their methods, their intellectual courage. Because ultimately, Appollonius of Myndus teaches us something about what it means to live philosophically. It means caring more about truth than about recognition. It means having the courage to stand alone when the evidence demands it. It means synthesizing different traditions and perspectives rather than rigidly defending one approach. It means being willing to be wrong, to propose hypotheses that might not pan out, to think beyond what you can immediately prove. It means contributing to a conversation that's bigger than yourself, that extends across centuries, that will continue long after you're gone. Apollonius did all of this, and he did it knowing, or at least he should have known, that he might be forgotten, that his works might not survive, that others might get credit for insights he had first. But he did it anyway, because the work mattered, because seeking truth mattered, because thinking clearly and courageously mattered. So here's what I want you to take from this. You don't need to be famous to matter. You don't need to have your name remembered to contribute to human understanding. You don't need to have all the answers to ask important questions. What you need is intellectual courage, careful observation, clear reasoning, willingness to challenge prevailing wisdom when the evidence demands it, openness to learning from diverse traditions, commitment to seeking truth wherever it leads. That's what Appollonius of Myndus did. That's what made him a pioneer, even though he's been forgotten. And that's what you can do. In your own field, in your own thinking, in your own life. You can observe carefully. You can think clearly. You can have the courage to question. You can synthesize different perspectives. You can propose new ideas. You can contribute to the long conversation of human understanding. You might be forgotten. Your name might not survive. Others might get credit for your insights. But the work will matter. The truth will matter. The contribution will matter. That's the lesson of Appollonius of Myndus. That's the gift of this forgotten pioneer. And that's what philosophy at its best has always been about. Not fame, not recognition, not building monuments to ourselves, but seeking truth, thinking courageously, contributing to human understanding, even if we're forgotten, even if our names don't survive, even if history credits others. The work still matters. The truth still matters. The courage still matters. Appollonius of Myndus looked up at a comet in the 4th century BCE and saw something no one else could see. Not an omen, not an atmospheric phenomenon, but a celestial body following its own path through the cosmos. He was right. and it took humanity 2,000 years to prove it. But in those 2,000 years, his idea survived. His approach inspired others. His example showed what intellectual courage looks like. That's legacy. That's what matters. That's what we're here to learn from. So go forth and think courageously. Observe carefully. Question prevailing wisdom when the evidence demands it. Synthesize diverse perspectives. Seek truth beyond superstition and conventional wisdom. Be a pioneer, even if you're forgotten, because the work matters, the truth matters, and the courage to seek it that matters most of all. Thank you.